morning students. Today topic is data encryption standards. Now we are discussing about working and process of DES. DES is developed in early 1917 at IBM and submitted to NBS to check the strength and security of the DES algorithm. DES is one of the landmark in cryptography algorithms, and it is based on Festal cipher structure. We will discuss later what is Festal cipher structure. We will discuss next video. And DES is a symmetric cipher algorithm and use block cipher method for encryption and decryption purpose. Up to now I have discussed about what is DES and who founded that in which year, and this DES is the landmark in cryptographic algorithm and Festal cipher structure is used, and symmetric cipher algorithm is used for both encryption and decryption algorithms. And this is about the process of DES. 64-bit plain text is input to DES and 56-bit is inputted to DES. One is plain text and 56-bit is key bit. And again DES producing 64-bit cipher text, and the size of the cipher text and plain text size is same, and the block covers the 64 and the key size is 56, and whereas coming to the plain text is 64-bit size. How can it will be exert? How it will works on it? This encryption is for block 1 and block 2 and block 3. If you take 3 blocks, then the entire process is repeat up to 3 blocks is closed. Now let us know about what is key discarding process. 64-bit original key size is converted to key discarding process, and every 8th bit of original key is discarded, and the resulting key is 56-bit. Why it produce 56-bit means we will discuss about this 56 result key in later. Now these are the main steps for DES. The plain text 64-bit is block is given to initial IP function, and the IP performs on 64-bit plain text to the block. After performing, the plain text is converted into two sizes of blocks. One is LPT and another one is RPT. LPT means left plain text and RPT means right plain text, and both are 32 bits. And LPT and RPT both are connected to 16-bit of encryption, and 16-bit of encryption takes input 56 keys, and the resultant key is 56B for 16 rounds of encryption. Let LPT and RPT perform 16 round of encryption process, whereas LPT and RPT rejoined and final permutations is performed on the combined block. The 64-bit cipher text block is generated finally. So these are the steps to follow the incrementing DES. And this is Festal cipher structure. You are seeing here the key generation and 32-bit are given to the 16 different operations are performed here in Festal cipher structure. This kind of 16 rounds will be performed in DES only. So this 16 round of encryption, I said already this will discussed in later. Now I am discussing about 16 bits and initial permutation IP and generate LPT and RPT. The plain text 64-bit initially permutation IP. Initial permutation performed only once. It applied only for plain text 64-bit and IP table is connected to each other. You already know what is IP table. And this is about IP table. And here the first bit is 32 and the middle bit is 19. We will reach 58 bit with one position and first bit with 40th position. This is only example. We will briefly discuss how to draw this table in next class. And RPT is produce IP output is divided into two equal halves known as LPT, and RPT of LPT minus 32 bit and RPT minus 32 bit, and the total size of the plain text is 64 bits, and those 64 bits are divided to two parts. One is LPT and next one is RPT. TS is a block cipher algorithm that takes the plain text in block of 64 bits and converts them to plain cipher text using keys of 48 bits. It is a symmetric key algorithm. Already you are seeing on the screen, it is a symmetric key algorithm, which means that the same key is used for encrypting and decrypting data. The general steps for generating keys are 16 rounds of encryption in the algorithm, and a different key is used for each round. How keys are generated is listed below, and the below schedule of the left shift is divided to two parts, that is CI and DI. Before that, inputs are taken and given to the permitted choice on PC-1, and those PC-1 is divided to C0 and D0. Up to the C will increase I-1 and D will increase I-1. And finally, those two C and D are connected to PC2, and finally we get keys. This is about key generation. And a compressed transpose is given to 64 bit into a 48 key using the key permutations, and divides the result into two equal parts C and D. And C and D are left shifted circularly for encryption around 1 to 9 and 16. They are left shifted circularly by 1 bit for all of the other rounds. They are left circularly shifted by 2. The result is compressed to 48 bits in according with the following DAS rules, and the rules are discussed in the next step. The step of our encryption is transpose the bits into 64 blocks according to the rules, and the result of step 3 is inputted for next round. And the original key K0, permitted choice is PC1 and choice 2 is PC2. Schedule of left shift is SLS. Divide the result into equal parts. Left plain text 1 to 32 bits and right plain text, that is 33 to 64 bits. The resulting part undergoes 16 rounds of encryption in each round. The right plain text is expanded using the permutation of the rules of DES. The expanded right plain text now consisting of 48 bits and XORed with 48 bit keys. The result of the previous steps is divided to 8 bits. And those 8 bits are seeing on the screen C0 and D0, CI to DI. Key I is PC second choice, that is PC2, and SLS CI-1, DI-1. And each box is reduced from 8 bits of 16 bits. The first and last bit of each box provides the row index, and the remaining bits provides the column index. These indices are used to look up values in a substitution box. The substitution box of 4 rows, 16 columns and containing the numbers from 0 to 15. This is the description, and this algorithm is encryption. Reverse the order of keys. It reads the keys in reverse order. You are seeing on the screen 16, 15, 14, like that the keys are read in reverse order. For example, IP undergoes the steps of encryption, and the first with SK16 undergoes 16th encryption round. If the SKs are 16, then it takes and it reads first 16 number only, then it reads 15, then it reads 14. Like that, it reverse order. It takes reverse order in the key. And the strength of DES is 56 bit of key having 2 power 56, 7.2 into 10 power 6 values, and the brute force of such looks hard. The machine performing 1 DES encryption for microsecond would take more than 1,000 years to break the cipher. And DES is a small change in either in the plain text or the key. The cipher text should change markedly, and DES exhibits a strong availability of effectiveness, and this is about the strength of DES. DES was provided in insecure. And this is about separates plain text as L0 and R0. And map n-bit plain text block to n-bit ciphertext block. N is equal to block length. For n-bit plain text and ciphertext blocks and a fixed key encrypt function is injected to next level. And E is Pn into K, and that tends to Cn. For all keys, K belongs to K, and S box is produced. The permutation P is now S invertible mapping written as E suffix K and X. The inverse mapping is description function, and Y equal to dk of X denoted in description of plain text X under K. And block cipher feature. And block size is generally large. Block size means greater secure, and key size, large key size means greater security. Large key space is needed for that, and there are S1 to S8 are there. This is called about S box. And F, it takes 32 bits and it converts by using E 48 bits, and finally 48 bits are added to S1 to S8, and that S is connected to P, and P finally we are getting 32 bits. The number of rounds, multiple rounds offer increasing security. Encryption modes define how messages larger than the block size are encrypted. Very important for the security and the encrypted messages. And facial network. Several block ciphers are based on the structure of the facial, and the facial network is fully specified given the n size. N is equal to 2W, and the number of rounds D, and D round function is F1 to Fd, and F1 to Fd are denoted with 0 and 1. Used in DS and IDA, RC5 and many other block ciphers are used in AES and facial network. If L1 equal to this is initial permutation, that is IP initial permutation. Your screen on the screen, one box. This table specifies the input permutation on a 64-bit block. This meaning is follows: the first bit of the output is taken from the 58th bit of input, and the second bit from the 50th bit, and so on. with the last bit of the output taken from the 7th bit of the input. We are seeing on the screen 7th bit, 58 and 50. This information is presented as a table for the easy purpose of presentation. It is a vector, not a matrix, and we will apply some XOR gate for F and 48 bits. Here you are seeing on the screen one diagram, but they are switched in the pre-outputs XOR gate between E table and S box, and the final IP table is, you are seeing, the final permutation is in the inverse of the initial permutation. And the table is interpreted similarly. That is, the output of final permutation has bit 40 of the pre-output block as its first bit, bit 8 as its second bit, and so on until bit 25 of the pre-output block is the last bit of the output. E is expansion function. Here E is expansion function, which takes a block of 32 bits as input and produce a block of 48 bit as output. 16 bit appear twice in the expansion. And this is about S box. S boxes are only non-linear elements in DES design. For S box it takes 6 bits. And finally it shows 4 bits. Each of the unique selection function S1, S2 up to S8 takes a 6-bit block as input and a 4-bit block as output. S is equal to matrix 4 into 16 because we are taking 6 and 4 blocks here, bits for 4 into 16 values from 0 to 15. B is 66 bit long, B1, B2, B3, B4, B5 up to B6, and B1, B6 are equal to row of matrix 2 bits, that is 0, 1, 2, 3, and B2, B3, B4, B5 are C, column of matrix, that is 4 bits 0, 1, 15 up to 15, and C is 4 bit long, that is binary representation of S of R, 4. These are S blocks. For example, B equal to 1, 0, 1, 1, 1, 1. Now B1, B6 are 11 row 3, and B2, B3, B4 are 0, 1, 1, column 7. Finally C equal to 7, that is 0, 1, 1. Another example, B is equal to 0, 1, 1, 0, 1, 1. Then what is C value? S of Ij is less than 16, can be represented with 4 bits, that is 15 columns and 7 rows. Matrix PC1 and PC2 are given by the standard DES. Petty check bit, that is 8, 16, 4, 32, 40, 48 and 56. Are not chosen, they are not appear on the PC1, and PC2 selects 48 bit subkey for each round from the 56 bit key schedule state. and DES use 16 48-bit keys generated from a master 56-bit and wake keys. Key makes the same subkey to be generated in more than one round, reduce cipher complexity, and weak keys can be avoided at key generation level itself. And description uses the same algorithm as encryption, expects that the subkey K1, K2, up to K16 are applied to reverse order, and the password is encryption function of the system. The password uses DES keys and all 0 blocks in encrypted always with the same key. For 25 DES rounds slots used to address dictionary attracts, and this string is used to algorithm one of the 4096 different ways. 12-bit slot is chosen randomly. Stored with the password. Slot creates 4096 in different DES functions. If the ith bit of the slot is set non-zero, then the bit I and I plus 24 of the output of the expansion function are swapped, and the resultant password will have different encryption in the password file. Dictionary attack is still possible. And the block cipher encryption mode, ECB message is broken into different blocks of block size bits. Electronic code book, each block encrypted separately. And the property of ECB, deterministic, the same data block get encrypted the same way. This reversal pattern of data when a data block repeats. This is about key generation. And error in the ciphertext block does not propagate, and it is not recommended to encrypt more than one block of data. And cipher block chaining, next input depends upon the previous input. Randomized encryption, and the properties of CBC is cipher block chaining properties are randomized encryption. Repeated text gets mapped to different encrypted data. Can be proven to secure assuming that the block cipher has disappeared property and that random are used. A cipher text block depends on all preceding plain text blocks. Reorder affects description, and errors in one block propagate to two blocks. 1 bit error in CJ affects all bits in MJ, and 1 bit in MJ plus 1. Sequential encryption cannot be parallel. Chooses random and protects the integrity of all the usages of keys. And the keys are L0, R0. L1 consisting of first 6 bits and R0 consisting of last 6 bits. The key K has 9 bits. The ith round of the algorithm transforms an input Li-1, Ri-1 to the output Li, Ri using an 8-bit key Ki from K. The main part of the encryption process is a function f of Ri-1 and K that takes a 6-bit input and Ri-1 and an 8-bit input Ki produce a 6-bit output which will be described later. The output of the ith round is defined as Li equal to Ri minus 1 and Ri equal to Li minus 1 XOR. The description is reverse of encryption. You are seeing on the screen. And this is the operations of F function. For Li 0 1 1 0 0 1. Expander of E is 0 1 0 1 0 1 0 1. And S box reads inputs. The input for S box has 4 bits. The first bit specifies which row will be used for 0 for first. And the other PT bits represents a binary number that specifies the column 000 for the first column and 001 for the second column and 0001 for the seventh column. For example, an input 010 for S1 box will aid the output 110. The key consisting of 9 bits. Ki is the key for the ith round, starting with the ith bit of k. Let k equal to 0 1 0 0 1 1 0 0 1. Then k4 is equal to 0 1 1 0 0 1 0 1. And finally Ri minus 1 is 1 0 0 1 1 0. And ki is 0 1 1 0 0 1 0 1. And this is about encryption. Cipher feedback is encryption model. The message is XORed with the feedback of encrypting the previous block. And the same encryption function EK is used here. For decryption. And the properties are randomized encryption. A ciphertext block depends on all preceding plaintext blocks. Reorder affects description. And errors propagate for all several blocks after the error, but made is self-synchronizing. And decreased through can vary number of bits feedback and trading off throughout for ease of use. Sequential encryption and constructs the random number generating using DES of EK. And next one is output feedback. It is also randomized encryption, sequential encryption, but pre-processing possible. Error propagation is limited, subject to limitations of stream cipher. And counter model, another way to construct PRNG using DES. And CI is equal to MI XOR of EK. And the counter is N plus I, number used only once, and equal to and fourth initial vector. And sender and receiver shares and does not to be secret. And the secret key is here K. Software and hardware works efficiently with different blocks encrypted in parallel. Pre-processing encryption part can be done offline, and when the message is known just to the XOR, the random access description of block can be done in random order. Very useful for hard disk encryption. Message of arbitrary length is ciphertext, same length with the plain text. And the weak case outcome of choice is 1 PC1. and key schedule lead to round keys K1 to K16 being either all zeros, all ones or alternating 0-1 pattern. Since all the subkeys are identical and DES is special network and DES has also semi-weak keys which only produce two different subkeys. Each used 8 times in the algorithm. We can refer to them as K1 to K2 and can refer to them property that EK1, EK2 of X is equal to X. There are 6 pairs of DES semi-weak keys. And let us discuss about brute force. Brute force. It's a plain text attack. 2 power 56 possible keys are accepted in this force. And DES challenges a series of brute force attack consisting of created by RSA security. To improve the security of block cipher, one might get the idea to simplify use two independent keys to encrypt the data twice. Any match between these two resulting sets are likely to relevant the correct key. Once the matches are discovered, then they can be verified with the second test set of plain text and cipher text. If the key size is n, this attack uses only 2 power n plus 1. For double DES, 2 power 56 plus 1, that is 2 power 57, encryption and decryption is constructed to attack each other, which nodes encryption and zero space, and all three keys are independent. K1 and K2 are independent. K3 equal to K1, K1 equal to K2 equal to K3. After finding several bits, the brute force for the rest of the bits to find the keys. At the time DES was designed, others already know about differential cryptanalysis. S boxes were designed to reset different cryptanalysis against 8 round DES. Such attack required 2 power 38 plain text cipher text pair. And another attack is founded linear cryptanalysis of DES. In 1993, it is founded. Instead of looking for isolated point at which a block is cipher behave like something simpler to involve trying to create a simple approximate to the block cipher as a whole. It is an attack that can be applied to an cipher. And this is about key generation. And these are the strengths of DES. Variable key length, mixed operators, used more than one arithmetic, Boolean, nonlinearity, data dependent rotations are acceptable here, key dependent S boxes, lengthy key schedule algorithms, plain text block length, variable number of rounds, operations on both data halves each round. Reduce the key says 72-bit, too short to with the standard brute force attack and Xbox are classified. Brute force search looks at a mechanism perform on DES encryption for microsecond would take more than 1,000 years to break the cipher. And this is the textbook. Many of the persons asked about the reference textbook, that is William Stalling by Cryptography and Network Security. This is the other name. That's all for today. If you have any doubts, contact me.